So what if this state machine has to be constructed making use of a flip-flop, and that is straight away to be implemented with a T flip-flop. That procedure, soon after having this in our hand, we need to construct a state table, the table which gives the information regarding the present state and that transition, etc. A state table having present state, all right, and next state with x equal to 0 for the input, x equal to 0, and for x equal to 1, and also the output with when x equal to input x equal to 0 and input x equal to 1 from this given state machine. All right, so present states, and we have 4 states over here: 0 0 0 1 1 0 1 1. It says we need to have 2 flip-flops. Like where do we get that information from? Like 2 raised to m, where m is the number of flip-flops, and 4 states, so we have 2 raised to 2, which is equal to, like this has we need 2 flip-flops to finish the construction for this state machine, having these states, these present states and next states. All right, so the states, present states, like we go for 0 0 0 1 1 0 and 1 1. So these are the states, present states. And what if what these lines indicates, like this indicates the transition from the present state to the next state, and these red arrows, all right, that information which we have to grab from the given state machine. These arrows indicates, this one in red color indicates the transition from the present state to the next state, and this one the value in red color indicates the input for which this transition occurs, and the value after the slash over here, like this one and this one are the corresponding outputs. All right, the value in the digit in the red color over here are the inputs which causes the transition from the present state to the next state, and the value after the slash in the green, for you to be clear, in the green are the corresponding outputs, and these has to be, the state table should contain all these information. For example, like getting back to the circuit, like present state, it is a 0 0. All right, so here let's talk about this one, present state 0 0. Present state is 0 0. What will be the next state when the input is 0? In the sense, watch carefully here, for this state, staying at this state, for input x is equal to 0, this has the next state is also that itself. The next state is present state itself, so we need to plug in for the present state 0 0 with input x equal to 0. With input x equal to 0, the next state is also the same, 0 0, and the corresponding output will be this as in the green color, the corresponding output for 0 0 when the input is 0. The next state is 0 0 itself, and the output is what it says after the slash, it's a 0. All right, in the same way, for the 0 0, for the machine, for the state 0 0, what will be the next state when x equal to 1? Here the same state, this one, I guess here, this is the input which causing the transition from present state to next state over this side. Where did I get that information from? Here this arrow says, this arrow indicates that this from 0 0, the next state will be 1 0 for the input 1. All right, so for the 0 0, present state 0 0, and the next state with x equal to 1, the next state will be 1 and 0, and the output being 1. All right, this information, this is for x equal to 0, the next state, and x equal to 0 for the output, and this one x equal to 1, the next state, if 0 0 is the present state from the machine. All right, this one, and the corresponding output is 1. That information is obtained from this indication. All right, the next one 0 1, talking about this one, this state, present state is 0 1 with x equal to 0, where it is with x equal to 0, yeah, this is the input. The next state will be 1 and 1, and the corresponding output is 0. This one, this indicates it's a 0. All Alright, with x equal to 0, with x equal to 0. The next state is 1 1, and then the corresponding output is 0. And for the same state, with x equal to 1, here this one, with x equal to 1, this one, the next state is 0 0. The next state, this is the indication, the next state is 0 0, and the corresponding output is this one. After the slash, the corresponding output is 0. And what about the next one? 1 0. 1 0 over here, 1 0 over here, with the x equal to 0. With x equal to 0, here this arrow indicates that 0 over here with the input 0, the next state is the same, even the next state and present state are same. Alright, in the sense here with the x equal to 0, no change in the state, it's 1 and 0, and corresponding output is 1 here. Corresponding output is 1. And for the same state 1 0 with x equal to 1, input 1 here, input 1, the next state will be 0 1, the next state will be 0 1, and the corresponding output is 0. And this one 1 1 with x equal to 0, the next state here, which one? The 1 1, the next state is towards 0 0 with x equal to 0, this one with x equal to 0, the next state is 0 0 0 0, and the corresponding output is 1. Alright, x equal to 0, output for x equal to 0, 1 1, the next state is this one, and the corresponding output is 1. And for this very state 1 1 with x equal to 1, here with x equal to 1, the next state is 1 0, the next state is 1 0, and the corresponding output is 0. Alright, this is the state table of the given state machine. And soon after this, we need to go for a excitation table, which includes the state table of the given state machine, and also the excitation for the flip-flop. For this example, like what if this state machine has to be constructed making use of T flip-flop, so the excitation table contains the information of this one as well as the flip-flop excitations. Alright, so excitation table for this one, once again we will have that present state and input, and also next state, present state, and the next state for different values of 0 and 1. And also we need 2 flip-flops. Alright, initially that was discussed. For 4 states, we have 4 states, and so we will be in need of 2 flip-flops to obtain the construction. 2 flip-flops, and then 2 flip-flops in the sense let that be given names TA for one flip-flop and TB for the second one, and the corresponding output. Excitation, these are the features which contains the excitation table, and then making use of the K-map reduction and all, we can go for the hardware implementation. Alright, so present state, that itself, that will reflect over, the excitation table is nothing but the information from the state table itself. In between we will have that, we will include the behavior of the T flip-flop. Why? Because we wanted to implement this state machine using a T flip-flop. Alright, so present state 0 0 and 0. Alright, 0 0, present state 0 0 with the input 0, in the sense 0 0 with the input 0, the next state is 0. Listen here, the hidden for a beginner, the hidden fact over here. For the present state 0 0 with the input 0, the next state is 0. In the sense for the present state 0 0, the next state being the input being 0, the next state is 0. Alright, 0 and 0. Alright, and for the same 0 0 state, when x equal to 1, it is 1 0, in the sense 0 0 1. When the input is 1 for this for the state 0 0, when the input is 1, the next state is 1 and 0. Alright, and for 0 1, so let's plug in over here, like 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 and 1. Alright, so getting back to the state table, for 0 0 input is 0, the next state is 1 0. In the sense 0 0 0 with input 1, the next state is 1 0. Alright, for 0 1, for the input x equal to 0, the next state is this one. Alright, for 0 the present state being 0 1 with the input 0, the present state being 0 1, the input being 0, the next state will be 1 1, the next state will be 1 1. We are done with this one. Alright, for the state 0 1 with the input 1, for the state 0 1 with the input 1, the next state is 0 0, that is obtained from the state table itself. Alright, this one. And 1 0 for the state, the present state 1 0, and x equal to input x equal to 0, the next state is 1 0. Alright, 1 0 and 0, 1 0 and 0, the next state is 1 0, 1 and 0. And for the same 1 0 state, when the input is 1, 1 0 state when the input is 1, 1 0 state when the input is 1, the next state is 1 0 when the input is 1, the next state is 0 1, the next state is 0 and 1. And for 1 1 when x equal to 0, 1 1 when input is 1 1 when input is 0, 1 1 when the input is 0, the next state is 0 0, the next state is 0 0. And for the same 1 1 with the input 1, the same 1 1 with the input 1, the same 1 1 with the input 1, the next state is 1 0, the next state is 1 and 0. This information is from the state table itself. Now we need to plug in the excitation for TA and TB. Why? Because we are trying to implement this state machine with a T flip-flop. Alright, so for that one need to have the basic knowledge on the truth table of a T flip-flop. What it says, T, the next state, the present state Qn, Q of n plus 1, the next state 0 0. If the present state is 0 with the T input, no change, so it will continue as it is. And for the same 0 0 1 case, the input is T, the present state is 1, no change, so it will continue. The truth table for a T flip-flop. And 1 0, it toggles, so input is 1, the present state is 0, and the next state will be 1 according to that characteristics of the T flip-flop. And input is 1, the present state is 1, the next state will be toggling from 1 to 0. Alright, so this is the flip-flop, the truth table of T flip-flop. Now this has to be plugged in over here, these values over here. Let me explain how that is done. Forget about the input for the time being, forget about this column, forget about the input for this one. Okay, so here pay attention, let this be A here, let this be A, and let this be B, let this be A, and let this be B. See, can you see this? AB present state, and the next state is also, the next state AB is also 0 0. Present state is 0, next state is also 0 0. In the sense, there is no change in the A and there is no change in the B also. In the sense, there is no change in the input TA and there isn't any change in the input TB also. So no change, so it's a 0 and it's a 0. Alright. The next one. Here A 0 0 and 1 0. If you watch carefully, this isn't toggling. Same states. B is same. No change in the B. So it's a 0. Whereas 0 and 1, in the sense the first flip-flop has a toggle and the corresponding toggling 0 and 1, so input is 1 for TA. Alright, on the other hand, the next one 0 1 and 1 1, which one is toggling? 0 1 and 1 1, 0 1 and 1 1. Once again the same way, like it's toggling, it's 0 and 1. There is a toggle for the first flip-flop, so it's 1, and 1 1, it's a 0 again. Alright, so 0 0, the next one 0 0 1 0 0. Now in this case, there isn't any change over here. A, the first one, there isn't any change over here, but there is a toggle over here. Alright, so there is no change in the A bit. A it's same, so no change, so TA will be 0. But there is a toggle over here, it's a 1, and the next state is toggling to 0, so the B flip-flop will be, the input is 1, toggling state. Alright, so 1 0 1 0, the present state is 1 0, the next state is also 1 0, no change in both the flip-flops, so 0, it continues with the 0 and 0. And 1 0 0 1, absolutely both are in a toggle position, 1 0 0 and 1, so 1 and 1, both the flip-flops will be having inputs 1 and 1 because it's toggling. And 1 1 0 0, again both are in toggling condition. Yeah, we go for that one. 1 1 1 0, 1 1 and 1 0, see there isn't any toggle over here. A is same, but B 1 and 0, so A got no change and B has toggling, so it's a 1. Now what to plug in with this column, what values comes over here? This one, from input 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1, this appears over there, so 0 in this manner. Okay, 0 for input 0, which condition? Once again, present state is 0 0. Alright, present state is 0 0, and for what will be the corresponding output, it's a 0. X equal to 0, it's a 0. X equal to 0, input x equal to 0, it's a 0, like. Alright, so this appears as it is in this manner, in this one. Then comes over here 0 1 here, 0 1 and 0 0 0 0 0 0. I'm done with this one. Let's check for 0 1 0 1 with input 1, it's a 0. For a 0 1 with the input 1, the output is 0. That's it. Alright, then come over here, it's a 1 0 1 0 1 0 1 0. Cross check, go for this one. For the input 1 1, I mean for the present state 1 1 with the input 1, the output is 0. The present state 1 1 with the input x equal to input 1, the output is 0. Alright, so this is the excitation table. Now with the help of a K-map, we're gonna decide what is the input for TA and TB. For that we don't need this one. Alright, even okay, like we are obtain the required information from the given state machine, so we don't need this one. I guess no, we don't need this one also. Alright, making use of the excitation table itself, we can go for the implementation making use of the T flip-flop. And T, for expression for T, the construction inputs for T, making use of AB and input X. So how it is done, making use of a K-map, it's a K-map over here with X over this side, and very well known that it's a 0 1, and AB over this side, AB with the 0 0 0 1 1 1, alright, 1 1, and here with what do we have, 1 and 0, that K-map cell positions. Alright, for 0 0 0, for 0 0 0, the input is 0, this one, it's a 0 here. So let's go for 1 straight away. Alright, so 1 we have over here, we're talking about the first flip-flop TA. 0 0 1, we have a 1. 0 0 1, we have a 1. Where is that? 0 0 1, we have a 1 over here, it's a 1 over here. 0 0 1, alright, 0 0 1, we have a 1. And where else? Which one did I finish? 0 0 1, it's a 1. I'm done with this one, I'm done with this line. Alright, I'm done with 0 1 0, 0 1 0, we have a 1. 0 1 0, 0 1 0, we have a 1 over here. 0 1 0 1 0, I'm done with this one. And with the other one, 1 0 1, alright, 1 0 1, we have a 1. 1 0 1, we have a 1. 1 0 1, we have a 1 over here. 1 0 1, we have a 1. This one, 1 1 0, we have a 1. Which 1 1? 1 1 0, 1 1 AB, 1 1 0, we have a 1. 1 1 0, we have a 1. Now the rest of the cells are filled with 0. And how to reduce this one? Guys, this forms a pair, isn't it? This one, these two form a pair. So TA will be equal to, from this one, this plus these two adjacent cells, isn't it? So from this one, what do we have? Watch carefully. From this one, it's a ABX, isn't it? ABX. And from this cell, what do we have? 0 1 0. So it's a 0 1 0 from this cell, and 1 1 0 1 1 0 from this one. Which one is toggling? This is redundant. This will be reduced over here. So we are left with 1 and 0, which is BX bar plus these two, this one, these two form a pair, isn't it? Plus. And once again for ABX, what information this cell gives us? It's a 0 0 1, and this one it gives 1 1 0 1 1 0 1. Something is toggling. Yeah, here this will be reduced, and we don't have that anymore. And so we have B bar X. All right. So TA can be like implemented like this one, like where to draw it. TA can be implemented like, go for a TA. Yeah, this is the input TA with the output QA. All right, with the output QA, or A, simply A with the output A. 2 flip-flops, isn't it? And obviously this will be A bar. And we have a clock also. I didn't forget this one. Now over here, so what comes over here? This one. These two implemented with the AND gate, in the sense we have B over here, B input B, and X bar over here, X bar, and input B, this one, to AND gate. All right. And this one also, we also have B bar input, and also X, which is also given to AND gate. These two are given to OR gate, and the TA will be equal to BX bar plus B bar X from these two cells according to the reduction, and then given to input to the A flip-flop, this one. We also have that clock, okay? We also have that clock somewhere from clock. We also have that one. So this is how to construct for a first flip-flop. What about the second one? The second one, because I need the place, all right. The second one, the same, like for TB, once again K-map reduction, making use of the K-map reduction. This one, this, and this. Once again, X over this side with the 0 1, and AB over this side, AB, it's a 0 0 1 0 1 1, and I'm very sorry, I made a mistake over here. 0 0 0 1 1 1 and 1 0. All right, so let's find out if where are the ones for TB. Straight away, these guys, we don't need to consider this one. This is needed. 0 1 0 1 and 1, the cell containing 0 1 and 1, it is 1 for the TB. 0 1 1 1, 0 1 and 1. All right, we have a 0, where is that? 0 1 and 1, we have a 1. 0 1 and 1, we have a 1 over here, this one. And the other one, it's a, we have this one over here. All right, 1 0 1, we have a 1. 1 0 1, we have a 1. 1 0 1 comes over here, we have a 1 over here. 1 0 1. All right, 1 0 1. 1 0 1, we have a 1 for TB. And also 1 1 0, we have a 1. 1 1 0, we have a 1. 1 1 0, we have a 1. And also this one, and also this one. 1 1 1, also we have a 1. 1 1 1, we have a 1. Alright, so how to reduce this? It will be having 3 terms. Alright, why? Because these two, first these two, let's go for these two, and so TB over this side, expression for TB, that will be equal to from these two, this pair, from this pair, what do we have? We are making use of A B into X, isn't it? So this gives 1 1 0 from this cell, and this cell gives 1 1 1. So what do we have? This gets, we don't like, this gets redundant, and we have AB from that pair plus. All right, we are done with this one. Let's go for this pair, 1 and 1. From this cell, what do we have? From this cell, 0 1 1, ABX once again, 0 1 1 from this cell. It's a 0 1 1 from that cell, and this one 1 1 1 from this cell. It's a 1 1 1, and this one, this gets redundant, this one. So we have BX from here plus, and this one we also have this pair. It's like, this cell has 1 1 1 1 1 1. Once again, ABX, we have this cell gives 1 1 1 1 1 1, and this one gives 1 0 1 1 0 1. All right, so in that case we have AX. So this one, TB will be AB plus BX plus AX. So how to implement this one? How to implement the TB part? TB, actually that comes over that side. All right, whatever, just implementing this one, TB. And the other flip flop, we have let this be, no, like we have that TB, input TB, all right, with the output B, and this will be B bar, this will be B bar. All right, so this one, A into B, AB, input A, and B to the AND gate, which gives A dot B over here, and this one AND gate with the B and X. All right, and this one another AND gate with the input A, X, and together to OR gate, and input to the TA. That's how we implement the second one. And also, of course, we have a clock pulse over here. The same clock pulse is given over here. So this is for the states, the present states and the next states. So what about the output? We also need to show the output, corresponding output also. Even the same thing, making use of, we are done with these two. All right, we have done with these two, and K map for ABX in terms of output in terms of AB and input X. All right, so for output, what do we have? Once again, the K map between X over this side with the 0 and 1, and it's a B over this side, it's a 0 0 0 1 over here, and we have 1 1 and 1 0. All right, so where's that? Where are the ones? 0 0 1, so 0 0 1 0 0 1, straight away that one. 0 0 1, we have a 1, and over here 1 0 0, here this one, 1 0 0, we have a 1, 1 0 0, we have a 1. I'm done with this one. 1 1 0, we have a 1, 1 1 0, we have a 1. All right, I'm done with this one, guys. Yeah, once again cross check. 0 0 1 0 0 1, we have a 1. 0 0 1, we have a 1, and here 1 0 0, we have a 1. 1 0 0, we have a 1, and also 1 0 1, we have a 1. 1 1 1, we have a, how many ones do we have? Yeah, 3. That's it. Yeah, that's it. So output will be from this one. This forms a pair. So output, output for the output, the expression will be from here. From here, it's a B X, and this cell we have 1 1 0, and this one 1 0 1. So which one is toggling? So guys, we only have A plus. All right. Oh no. We'll have 2, isn't it? So it's a 1 1 0. It's a 1 1 0 and 1 0 and 1 0. This cell gives 1 0 0 1 0 0, and so the final will be A from here. There's a toggle, so this gets cancelled, and X bar plus this one gives straight away no reduction over here. It's a plus 0 0 1 from this cell, so it's a bar B bar into X. All right, 0 0 1. So this is, so how to implement that output? For the output, we have AND gate with inputs A and X bar. All right, A and X bar. Another AND gate with 3 inputs, A bar, B bar and X, and these 2 inputs are given as input to OR gate, which gives finally this one. This is how we implement the given state machine making use of a T flip-flop. Thank you.